Hello and welcome to our lesson on dot and cross diagrams. This is part 1. So the first thing you need to know if you are doing a dot and cross diagram is whether you are doing an ionic dot and cross or a covalent dot and cross. If you have a metal and a non-metal, that is an ionic dot and cross diagram, ionic bonding. And if you have a non-metal and a non-metal, you have a covalent dot and cross diagram. How would you know if it's metal or non-metal? Well, you will always have a periodic table in front of you. Use your common sense. Everything to the left of the line, the zigzag line, is a metal, and everything to the right of the zigzag line, including hydrogen, is a non-metal. So beware the hydrogen. On your periodic table, hydrogen appears at the top of group 1, but it is a non-metal. Okay, so why don't you pause the video and have a go at deciding if sodium chloride is ionic or covalent. Okay, well, sodium is here and it's a metal, and chlorine is here and it's a non-metal, metal and non-metal, so it's going to be ionic bonding, and we're going to do an ionic dot and cross diagram. Pause the video and have a go at nitrogen chloride. So nitrogen is group 5 over here, and chlorine again over here. So we have two non-metals, and therefore this is going to be covalent bonding. Pause the video and have a go at carbon dioxide. Okay, so carbon is here, it's a non-metal. Dioxide, do not be fooled, di just means one. You're looking for what element that is. Hopefully you would recognise oxygen, which is here. Don't be fooled by di. So two non-metals again, and therefore a covalent bond. Pause the video and have a go at potassium triphosphate for me. Okay, so potassium is here, and hopefully you would recognise tri as something that is not on the periodic table. Tri just means 3. You hopefully recognise phosphate, phosphorus, which is here. So a metal and a non-metal. So we have ionic bonding. Also here you have 8, which is oxygen as well. So this is actually a metal and a non-metal and a non-metal, but it's still ionic bonding because you have that mixture of metals and non-metals. Okay, so let's look at this exam question. And for now, I would just like you to pause the video, have a look at the information and decide what you have been asked to do. Are you being asked to draw ionic bonding, or are you being asked to draw covalent bonding? Okay, well, there's lots of information. I'm going to come down to the bottom paragraph. Use the dot and cross model to explain the bonding in both O2 molecule. So O2 is 2 oxygens, so that's a non-metal and a non-metal, even though they're the same. There's oxygen, so that's a covalent bond between 2 oxygens. And in CaO, so calcium is here. Obviously oxygen is a non-metal, so we have an ionic bond. So this was actually a 6 marker, and it really wanted you to do both of these. So you had to do a covalent dot and cross diagram for oxygen, and you had to do an ionic dot and cross diagram for the calcium oxide. Okay, so the next step then is knowing which type of dot and cross diagram you're drawing. So you know it's ionic or covalent. Is that the one with the brackets, or is that the one with the crossover? Kind of looks like a Venn diagram. So ionic bonding, what you're looking for, what do you need to do? Well, it's got ions in it, hasn't it? Ionic bonding, ions. What is an ion? It's an atom that has lost or gained electrons to become electrically charged. So an ionic bond, a dot and cross diagram, will have those ions. And if it helps, I always think that these brackets kind of look like an eye. So when I'm thinking, oh, which one is it? Which dot and cross that I'm doing? I'm thinking it's the one with the brackets because that looks like an eye. For covalent bonding, a covalent bond is a sharing pairs of electrons. And for me, if it helps, again, I kind of think that sharing area looks like a C. So in my head, that's what I'm imagining when I'm thinking, okay, which is it? Is it the brackets or is it the sharing one? And I use those letters to help me. Okay, so you're happy it's ionic bonding. You know that's the one with the brackets and the pluses and the minuses. But how many times do you draw each ion? Is it 1 lithium or is it 2? Well, often the question will actually tell you. Let me give you an example. So here it says chlorine reacts with sodium to make sodium chloride, NaCl. But that's your formula, 1 sodium and 1 chlorine. So that's what you draw, 1 sodium and 1 chlorine. Here's another one. Use dot and cross models to describe the bonding in both sodium oxide and in a molecule of oxygen, O2. This is where a question would be harder. It hasn't given you the formula for sodium oxide. You'd have to work that out. But it does give you the formula for oxygen, which is O2. And so you know you're drawing 2 oxygens. Here's another one. Use dot and cross diagrams to draw the electronic structures of the 2 ions in Na2O. So 2 NAs, sodium, and 1 oxygen. It's giving you that information. If it doesn't tell you and you need to work it out, this is going back to knowing how to do ionic formulae. So I'll go through a couple here, but if you need more information, there are other videos you can be watching. So this one here, you're looking at Li plus 1. You know that it's in group 1 of the periodic table. It's going to lose 1 electron, so it's going to have a plus 1 charge. Chlorine is group 7. It's going to gain 1 electron, so it have a minus 1 charge. Now, as long as they're the same, we're happy. So I need 1 lithium and 1 chlorine. So the formula would be LiCl. For this one here, magnesium's group 2, so it loses 2 electrons, so plus 2. Oxygen's group 6, so it gains 2 electrons, so that's minus 2. Again, those numbers are balanced, they are the same, so to cancel each other out. So just need 1 of each. MgO is the correct ionic formula. This is a little bit more difficult because I've got lithium with a plus 1 and I've got oxygen with a minus 2, so they don't balance each other out. If I want to make a plus 2 to balance out that minus 2, I would need a second lithium, and so the formula is Li2O. For this one here, magnesium is plus 2, chlorine is minus 1. Again, they're not balanced, they're not the same. In order to make that minus 2, so I can balance them out, I would need 2 chlorines. So my formula for magnesium chloride is MgCl2. Bit of a cheat method if you want to know. I don't really like teaching this. You don't really understand what's going on. That's a shame. But if it helps, so be it. I will teach you it. It's called the jot and swap, or sometimes the drop and the swap, but you'll get the idea anyway. So here I have my ions. Those might be given in the question, or you might have to find them on the periodic table, but there we go. So first thing you do is you jot down the elements again, or the ions again, the letters Mg and Cl, and then you swap the numbers. So this becomes Mg1 and this becomes Cl2. Of course, you would probably just write that MgCl2, and that's your ionic formula. Okay, pause the video and have a go at this one for me, please. Okay, so I'm going to jot down the letters Li and O, and then I'm going to swap the numbers, so that becomes Li2 and O1, and so I would just write down Li2O. Okay, pause the video and have a go at this one for me, please. Okay, again, let's jot the letters down, Al and O, and then swap the numbers, so it'd be Al2 and O3. Al2O3, and that's the ionic formulae. That works every time, so if you find that helpful, do that, that's fine. Okay, so we've decided it's ionic. We know that's the one with the brackets and the plus and minus charges. We know in this example from the formula written down how many of each we need. So how are we actually going to go about drawing the dot and cross diagrams? I'm going to go through this one relatively slowly. If you're confident, you can pause the video and have a go yourself by all means, but there are another couple of examples coming up. Okay, so let's see. Well, first of all, let's do sodium. So sodium is Na, there's my nucleus. And I need to know how many energy levels. So if I look at my periodic table, period 1, period 2, period 3. Okay, so that's 3 energy levels. And it's group 1, so that's 1 electron in the outer energy level. What about the internal energy levels? Well, they're full, so that's 2 in the first and 8 in the second. Okay, now you'll notice I've drawn an atom rather than an ion. I'm trying to really show you what it would look like. a way you could start. If you really get stuck, you could just draw the atom and then think, well, okay, what would actually happen? And then start rubbing things out. But so say you've got this far, you've drawn the atom, you know it needs to be an ion, what are you going to do? Well, straight away I can see that outer electron needs to go, it's going to be transferred elsewhere, and so I'm going to get a rubber and I'm going to rub it out. Okay, so I'm going to rub out that outer electron. I'm going to get rid of the outer energy level. Now, obviously, the more confident you get, you would probably never even draw that outer energy level because you know it's going to disappear. But I'm just trying to show you what's actually physically going on here. Now it's an ion. I'm going to put those brackets around it, and I'm going to put a +1 charge. And that's my sodium done. I just need to now look at the chlorine. Okay, so with the chlorine then, here's chlorine. Again, I need to know the energy levels. So it's period 1, 2, 3, so 3 energy levels. This time it's group 7, so 7 electrons in the outer energy level, 2, 4, 6, and 7. Notice I've paired my electrons up. It just makes it less likely you add too many. It's easier to see and it's a lot neater. My inner energy levels then, I've got to fill those up, so 8 in that one, 2 in that. Now, of course, the other way of doing it, if you're not happy with groups and periods, is recognising that, of course, the number of electrons is the same as the number of protons. Chlorine has an atomic number of 17. So you could think, well, 17, that's 2 in the first energy level, that's 8 in the second energy level, because they're full up, and then I've got 7 left over in the outer energy level, and you could do it that way, you would have 17 electrons. Either way, it doesn't matter as long as you get the correct number of electrons. Okay, so straight away here I can see that I've got a gap. The outer energy level needs 1 more, and so I'm going to add it in. And you can see here I've done the dot to show that that electron has been moved, it's been transferred from the sodium. If you remember, the sodiums were done as dots, so it's really obvious that where it's come from. Now, if you don't do dots and crosses, it's not the end of the world as long as the numbers add up, but it just makes it easier for the examiner to see, and it makes it easier for you when you're checking yourself, is everything in order? Of course, if it's gained an electron, this is now an ion, so we put brackets around it, we add the charge, it's gained 1, so it's -1, and that's your chlorine done. Now I've done them on separate sheets because I haven't got enough space, but it would look something like this. So here's the nice neat version. You can see it's really obvious what's happened to that electron from sodium. It's moved across to the chlorine. It's really obvious what's happened. In an exam situation, they don't have to be next to each other. Just make it really obvious where your answer is and what you want the examiner to look at. If you make mistakes, just cross them out. Make it really obvious what you don't want them to look at, what you've changed your mind about, and what you actually said, this is my answer. Okay, it's your turn. Have a go at drawing lithium fluoride for me. You can see the ions there, Li +1 and F -1. Okay, so you may have started with something that looks a little bit like this. If you didn't, because you jumped ahead straight away to the ions, give me a second. So here's a lithium atom with that 1 electron in the outer energy level and fluorine needing 1 more electron in the outer energy level. So it makes sense that the lithium would transfer that electron and lose that outer energy level. That lithium is now stable, so I'm going to put a brackets around it and I'm going to say +1 because it's lost 1 electron. And the fluorine is now stable, it's got a full outer energy level with 8. It's gained 1 electron, so it would be a -1. And it should look something like this. If you skipped ahead and you did the ions straight away, absolutely brilliant, well done. Okay, have a go at lithium oxide for me this time. Be careful. The ions are Li +1 and O -2. Okay, so I've already done the first one for you with that lithium ion. It's already an ion. It's already lost the electron, and you can see that that electron has been transferred across to the oxygen already. And then, of course, well, that lithium is stable, but the oxygen still isn't. It still needs 1 more electron, which is why we need the second lithium to transfer its outer electron. It also loses its outer energy level and becomes a +1 ion. And now oxygen is stable, so we'd have those brackets with a -2. So these should now be should be balanced, +2 and -2. And the formula then would be Li2O. Okay, that's the end of part 1, guys. Make sure you watch part 2 on covalent bonding.